Hello ROS developers, welcome to a new video on how to develop with ROS. If you want to learn anything about ROS, this is your channel. ROS navigation, ROS with drones, ROS for autonomous cars, everything ROS is here. Learn ROS step by step and push your ROS learning with just minutes of video. Hi, I'm Arif, and today we are going to look at how to command joint position of a robot on Gazebo using a publisher in ROS. But before we start, remember to visit the Robot Ignite Academy, our online academy where you will find practical online ROS courses using simulated robots. No installation is required, and you will find the link to the academy in the video description below. Now let's go back to the question on Gazebo answers. It says, hello, I'm using this tutorial, Gazebo sim tutorial on ROS control to command my robot in Gazebo. I can control it using manual send example commands. You can already control the robot using manually as well as using RQT GUI to send commands. Now I'm searching to command it by integrating a publisher into node in ROS and sending random command to joints to let them move. Alright, so let's look into this tutorial, which is here. So this is a tutorial in the Gazebo website on how to integrate ROS control into a Gazebo model, Gazebo simulation. So it's a very good tutorial, so you should do this if you haven't. So it talks about adding transmissions, adding the Gazebo ROS control plugin. So as an example, this tutorial builds on the RR bot, which is a very simple robot, but very but good enough to be an example. So that's the transmission. This is the plugin. Then create a new package, put everything in a package, the YAML control config file, and finally a ROS launch file. Alright. So so this is how you can manually send commands to the robot, and this is also how to do it using an RQT GUI. So the OP said that he can already do all that, but he's looking to command it by integrating a publisher into node in ROS. So that's what we're going to do in this video. We're going to write a Python script which will create a node and will publish to some topics that will move this robot. So to do that, I'm going to use the ROS Development Studio, RDS, and let's create a new ROS jack. Name this RR bot control. And open. So if you are using ROS DS, ROS Development Studio, you could go straight to the simulations button here and grab RR bot. So this will launch a simulation of the robot, and then we are going to need the shell. We are going to also need an IDE and probably one more shell. So this is our robot. It's a very simple two joints robot. Alright, so that's joint number 1 and joint number 2. And if you see the robot swinging like this, it's freely swinging. That means that means most probably the controllers are not loaded. So how do we check that? We can do ROS topic list and can try to find there is no topics with the word controller or command or anything in it. So that's the first thing that we have to do. We have to launch the controller. So ROS launch rrbot control rrbot control.launch. Okay, so this is in ROS.ts. Okay, alright, so we can minimize this one. Let's look at the other shell. So now that we have loaded the controller, we should be able to see, oops, sorry, ROS topic list, my bad. Okay, so we should be able to see something like this: join one position controller slash command slash PID parameter description, parameter updates, and also the state. And there's also another set for join number 2, the command, the PIDs, and the state. So these are the topics that we are interested in when we are trying to control the robot. Okay, so let's do that. Let's try and publish to this guy the command topic. So ROS topic, pub, name of the topic, and double tap. Okay, so let's say the data I put here as 0.5, and there you go. So the robot move that much. So this is join number 1, yeah. Okay, let's try another number. Say let's put something big. So this number is actually in a radians. So that's 1.5 radians, yeah, not degrees, not some arbitrary number. It's in radians. Okay, so that's why you have 1.5 is approximately half of pi, so about 90 degrees. You can see that the joint now is about 90 degrees. Alright, so again what we are going to do now is to write the Python script which will send these numbers to be able to control the robots. Okay, so let's start with going into Catkin workspace, source, and create a new package. I will call it rrbot control with a dependency of ROS.py. Okay, let's go into rrbot control and create a directory called scripts. Okay, so let's look at our IDE here. So we now have in our Catkin workspace we have a source rrbot control, scripts, and inside scripts let's create a new file. We call it main.py, something easy. Okay, so we are going to create our code here. Okay, I'm going to use a template from the official ROS tutorials on how to write a publisher or subscriber in Python. Okay, so this is the most basic code to create a publisher. So we copy that. Oops, put it here. Okay, let's Control V. Alright. So of course we have to do some modifications to this code so that it talks to our robot through its topic, not through some chatter topic as per the tutorial. Okay, so let's see. So it says import ROS.py. Let's start from the top. Okay, so it's importing ROS.py. It's importing some standard messages, dev talker. Okay, so this is where we are going to do most of our stuff. Okay, so first we initialize a publisher, but not to the topic chatter. We are going to publish to this topic, the rrbot join one position controller command topic. Okay, is that, and it is not of type string. It should be, let's grab some info about this topic. So do ROS topic info and the name of the topic, and press enter. So it says that this topic is of type standard messages float 64. Okay, so it is not string, it is float 64. Okay, so from standard messages.message, we are not importing string, we are importing float 64. Alright, and then so that's the publisher. This is where we initialize the node. We can leave the name, you can put whatever name you want. In this case, I'll put RR.talker. Rate 10 Hz is good. Now in the while loop. Okay, so we are not going to do this. We are not going to say hello world, obviously. But we are going to send some numbers, some float number here. Okay, so let's say position equals to 0.0 or something, and we are going to log this number just so that we can see. I'm going to publish it as well. Okay, so rospy.loginfo will print out this number position in the shell, whereas pub.publish will actually publish it to the topic, through this topic. Okay, right, I think that's it. So save this and go back to our shell. Okay, first of all, let's see if our Python file can be executed. So that should be okay. Or you can do ls-l. You can see that it has executable permissions. Alright, so we are going to ROS run rr bot control and main.py. main.py. Okay, so that's our simulation. Now when we run this, there you go. So it now goes to the position of 0.0. You see that? So this is 0.0, and we are controlling join number 1 only. Right now we are publishing to join 1 only. Okay, so let's try another number, and remember this is in radians, yeah, radians, not degrees. So we can also import math, so that we can use pi. So for example, I want math.pi divide by 2. So that's half a radian, half a pi radians. So that should be about 90 degrees. Okay, so let's go back here and run this again. There you go. So the robot join 1 is now is commanded to go to 90 degrees, but of course because of the weight of the links, and also the probably also the PID parameter settings, so it is not exactly at 90 degrees. Well, that's expected in the real world, yeah. Okay, so there you go. This is how we program it. We write a Python program to control a gazebo simulation, a gazebo simulated robot. Okay, just to go further, we can also do this. We can also do math.sign. Let's do this. Let's put a variable called I. So we have to define I here. I equals to 0. I plus equals to 0.01, for example. And save. And then let's run it again. So as the simulation goes on, the value of I will be incremented bit by bit. So you can see that the arm is now moving because the value of sine I will be different at different times. So what's next? Next is to actually, there's a challenge for you to also include the controller or the publisher, in fact, to control join number 2. So right now we are controlling only join 1. So what you should have is another publisher which publishes to join number 2 instead of join number 1. Or maybe both together at the same time. Okay, so two publishers, one publishing to join 1, another publishing to join number 2. And then you can also play around with these numbers. Where do we want our robot to go to? Where exactly we want our robot to go to? Okay, so no, you can either put some random numbers, you can put some simple equations like this. It's up to you. So go ahead and play around with it. And that's all. If you like the video, give us a thumbs up and remember to subscribe to our channel and press the bell for our new video every day. Whether you like it or not, please share your thoughts and questions in the comments area. Peace out.